In this module, you will learn about different types of functions and their graphs. The relation f from a set A to set B is said to be function if every element of set A has one and only one image in set B. In other words, a function f is a relation if no two ordered pairs in the relation have the same first element. A function that is a relation between two sets can be represented graphically because it is the set of ordered pairs and can be plotted on the Cartesian plane. The notation f from A to B means that f is a function from A to B, where A is called the domain of f and B is called the codomain of f. Given an element A from set A, there is a unique element B in set B that is related to A. The unique element B, to which f relates A, is denoted by f of A and is also called the value of f at A, or the image of A under f. The set of all the values of f of A taken together is called the range of f, or the image of A under f. Symbolically, the range of f is the set of all B such that B is equal to f of A for some A in A. In this case, the range of f is equal to the codomain of f. Let's now discuss different types of functions and their graphical representation. The first function we are going to discuss is the identity function. An identity function is a function f from set R to set R, such that f of x is equal to x for all x belonging to set R. An identity function is denoted by I with subscript R. Let A be the set having elements 1, 2 and 3. Then the function f defined on A by f of x is equal to x is the set of ordered pairs 1, 1, 2, 2 and 3, 3. This is an identity function. Since for this, both the entries or the elements in the ordered pairs 1, 1, 2, 2 and 3, 3 are the same, the graph for this function will be a straight line passing through the origin. Each point on this line is at equal distance from the coordinate axis. This straight line makes an angle of 45 degrees with coordinate axis. Thus, the graph of a real function f from R to R, defined by f of x is equal to x for all x belonging to R, is as shown. Now, let's see how the graph of a linear function looks like. A function f from R to R is said to be a linear function if f of x is equal to ax plus b, where a is not equal to 0, a and b are real constants, and x is a real variable. Consider the linear function f of x is equal to 3x plus 7 for all x belonging to the set of real numbers. Some ordered pairs satisfying the linear function are on plotting these points on the Cartesian plane and then joining them, we get the graph of the linear function f of x is equal to 3x plus 7 for all x belonging to R as shown. Let's now move on to the constant function. A function f from R to R is said to be a constant function if f of x is equal to c, a constant for all x belonging to R. Let f be a constant function from R to R, defined by f of x is equal to 4 for all x belonging to the set of real numbers. Some ordered pairs satisfying the linear function are. Observe here that in all the ordered pairs, the second element are the same. That is, the range has only one element, that is 4. In other words, if the range of a function is a singleton set, then it is a constant function. On plotting these points on the Cartesian plane and then joining them, we get the graph of the constant function f of x is equal to 4 for all x belonging to R as shown. Also from the graph, we can conclude that the graph of a constant function f of x is equal to c is always a straight line parallel to the x-axis intersecting the y-axis at 0, c. Let's now proceed to the polynomial function. A function f from R to R is said to be a polynomial function if for all x in R, y is equal to f of x, which is equal to a0 plus a1x plus a2x square plus so on up to anx raised to the power of n, where n is a non-negative integer and a0, a1, a2 and so on up to an are real numbers. Some examples of polynomial functions are f of x is equal to x squared plus 5x plus 6 and f of x is equal to x cubed plus 4x plus 2. Note that in a polynomial function, the powers of the variables should be non-negative integers. For example, f of x is equal to square root of x plus 2 for all x belonging to R is not a polynomial function because in this case, the power of x is a rational number. Let us now consider the polynomial function f of x is equal to 3x squared plus 2x minus 3 for all x belonging to the set of real numbers. Some ordered pairs satisfying the polynomial function are. On plotting these points on the Cartesian plane and then joining them, we get the graph of the polynomial function f of x is equal to 3x squared plus 2x minus 3 for all x belonging to R as shown. Now, let's learn about the rational function. Let f of x and g of x be two polynomial functions. Then, f of x divided by g of x, where g of x is not equal to 0 and x belongs to R, is known as a rational function. Let us consider the function f of x is equal to 2x minus 5 divided by 3x minus 2, where x is not equal to 2 divided by 3. Some ordered pairs satisfying the given function are. On plotting these points on the Cartesian plane and then joining them, we get the graph of the given rational function as shown. Now, proceeding to the modulus function. A function f from R to R defined by f of x is equal to mod x for all x belonging to the set of real numbers is known as a modulus function. If x is negative, then the value of the function is minus x. And if x is non-negative, then the value of function f is x. That is, f of x is equal to x if x is greater than or equal to 0, and minus x if x is less than 0. Some ordered pairs satisfying the modulus function are. On plotting these points on the Cartesian plane and then joining them. We get the graph of modulus function f of x is equal to mod of x. The next function that we are going to discuss is the signum function. A function f from R to R defined by f of x is equal to mod x divided by x is called a signum function. That is, f of x is equal to 1 if x is greater than 0, 0 if x is equal to 0, and minus 1 if x is less than 0, for all x belonging to the set of real numbers. Some ordered pairs satisfying the signum function are on plotting these points on the Cartesian plane and then joining them, we get the graph of signum function f of x is equal to mod of x divided by x. The domain of a signum function is the set of real numbers, and the range is the set having the elements -1, 0, and 1. It is also written as sin x. Now, let's discuss the last function, called the greatest integer function. A function f from R to R, defined by f of x, is equal to the greatest integer, less than or equal to x for all x belonging to the set of real numbers. Such a function is called the greatest integer function. From the definition, its value is equal to -1 for x is greater than or equal to -1 and less than 0. The value is 0 if x is greater than or equal to 0 or less than 1. 1 if x is greater than or equal to 1 and less than 2. 2 if x is greater than or equal to 2 and less than 3. This implies f of 2.5 is equal to 2, and f of 1.2 is equal to 1, and so on. Hence, the graph of the greatest integer function is as shown.